Before we get started, are there any questions over any of the homework assignments? Questions on any of the assignments so far? So, homework for yesterday. Yep. Really, we finished it. It's just, let's see here. Homework for yesterday was problems. 25 through 28. 31. 32. 35, 36. Or 352. If there's no questions on any of the assignments, we're going to look at the note sheet for today. So what we're doing today is we're using the completing the square method. So we're applying the completing the square method to this equation here, ax squared plus bx plus c. Now ax squared plus bx plus c, this is the general equation for any quadratic that we could possibly have, for any real values of a, b, c. So if we have numbers in a, b, c, this is a quadratic for any one equation we could possibly have. Now, we said that completing the square is the first method that we have that will solve any quadratic equation. So what we're doing is we're taking the method to solve a quadratic equation, works for any of them, and we're applying it to the general form for any quadratic. So the solution that we get from this here should be an equation that works for all quadratic equations. So this will be the second method. We're going to get to the second method to solving quadratic equations. Now, really, so we're taking ax squared plus bx plus c, doing completing the square. Now the first step in completing the square is a equal to 1. Is the number in front of x squared 1? No. So what we're going to have to do is divide everything by a. So it's going to get a little weird at certain points because we're going to be doubling up on some of the letters because like step 3, we're going to find the value of c, and we do have c in the equation. They're going to be different letters, different terms. So our ax squared divided by a is x squared. B over a x plus c over a is equal to 0. Because we're not going to be actually dividing b over a, because b and a could be the same number. They also more likely could be different numbers. They're just representing a number, a term. So we get x squared plus b over a x plus c over a equals 0. Step 2, get the constant term on one side and the variables on the other. So for this here, it means we're going to subtract c over a from both sides. On the left-hand side, we're going to still have x squared. We're going to have b over a x plus our space equals negative c over a plus our space. Because we get the variables on one side, constant terms on the other. Now, yes, a, b, c in this case are variables, but they are really standing in the place of numbers. Questions on this so far? Now at this point here, we're on to step 3. We want to find C, or b over 2 squared. We want to find this term that's going to make the left side of this into a perfect square trinomial. And for us here, the value of b is what? B over a. So we have b over a over 2 squared. Now normally at this point here, we would take what's inside the parentheses, plug it in the calculator, let it do it for us. Unfortunately, the calculator needs a value for both b and a. And what is b and a inside those parentheses? Well, it's any real number. It could represent, they're really at this point, b and a are representing every real number we could possibly have. So it's not possible to plug it in. But if we do this simplification and simplify it, what we're really looking at, you don't have to write this down, is that we have b over a over 2. We're just saying that we have b divided by a, which is being divided by 2. For us to do, or to divide fractions, we change it from division to multiplication and flip it, which just tells us that it is b over 2a. And the last thing we need to do is to square it. So since we don't have addition and subtraction on top or bottom, we're just multiplying it by itself. We can square the top. B squared, b times b, is just b squared. On bottom, we have 2a squared. We're multiplying it by itself. So we can see that the a is going to be squared, but we also have to square the 2, because 2a times 2a would give us 4a squared. And that's fine. We're going to put in these spots b squared over 4a squared, b squared over 4a squared, and we get this here. Now on the left-hand side, it's not too bad because, again, we turned it into a perfect square trinomial. So we're going to have a single set of parentheses being squared. We will have x inside this here like we've had before. And the term inside the parentheses would be b over 2a. And the sign between it would be plus, because it's positive. Now the right-hand side, we're going to need to add these two fractions together, because we're adding negative c over 2a and b squared over 4a squared. And for us to be able to add or subtract two fractions, the denominators have to be the same. Now one of the denominators is 4a squared. The other is 2a. So what do I need to multiply 2 by to get 4? 2. So we're definitely going to have to multiply the top and bottom by 2. Here we have a, here we have a squared. So we're also going to have to multiply by a, because 2a times 2a is indeed 4a squared. So that tells us that both denominators are going to be 4a squared. On top we have 2a times negative c, which is negative 2ac. I need to fix one thing because I'm looking, I'm like, that doesn't seem right. Does anybody see something wrong? Because at the top we have equals what? Negative c over a plus b squared over 4a squared. I put 2a. Because this 2 should not be here. It's almost like I knew where we were needing to go when I put it in there, because it really should be multiplied by 4a, telling us that this is negative 4ac. Wasn't big, but I'm glad I caught it now before we got any further. Questions on this here? Way too far. Now that the denominators are the same, we can add these two together. Now, is b squared and 4ac, are they like terms? No. Could they give us the same value or approximately the same value? I mean, yes, but that's going to depend on what a and c and b's values are. Because if we set it up in a place where ac times 4 and b squared have the same value, yes. But there's also just as many cases, if not way more cases, that they're not going to have the same value. So all we can do is just rewrite them. We can just add them together. Now, I'm going to put the b squared in front, just because, since it has a higher exponent technically according to our number theory, we write it in order of decreasing power and alphabetical order. So questions on how we got to this point here. Now we can start solving by square root in both sides. Now on the left-hand side, it's kind of nice. Square root and square will cancel. That means that we have x plus b over 2a equals plus or minus. Now, just like we did yesterday on the last problem, we're really just looking at the square root of the numerator and square root of the denominator. When we take the square root of the whole thing, we can break it up into the square root on top and square root on bottom. It should be. It is. It is a kind of theorem, and we're going to get to it here in a second. It should start looking more familiar in a second. Now, the denominator, square root of 4a squared. Our square root of 4 is 2, square root of a squared is a. Because we could say 4a squared is 2a squared. Because really, we can look at it as 2a squared. And we're taking the square root of it, so that square root and square would cancel, leaving us with 2a. Now, we could simplify the numerator if b squared minus 4ac, we could rewrite it like we did the bottom there, as a single set of parentheses squared, then the square root and square would cancel. But unfortunately, that's as far as it can go. We can't simplify the square root of our b squared minus 4ac. Just rewrite it in a different color. And the last thing we need to do is get the x by itself. So we're going to subtract b over 2a from both sides. B over 2a minus b over 2a is just going to be, leave us with the x equals negative b over 2a. Plus or minus our square root of b squared minus 4ac all over 2a. Pythagorean theorem would be a squared plus b squared equals c squared. Now let's write this a little bit nicer. Now, since the denominators of both of these fractions are the exact same, we can actually combine them, we can add them and subtract them technically. So it gives us negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. The quadratic formula is the second method that we have for solving quadratic equations that works every time. Giving any quadratic equation of the form ax squared plus bx plus c equals 0. We can solve it using this equation, where we plug a, b, and c into a, b, and c respectively. There's our a. We'll plug a in here and here. Our value of b, don't want that. B, we'll plug it in here and here. And C, we plug its value in here, simplify, and we get our answers. And we know this works because completing the square solves any quadratic equation, and since we applied it to the general form for any quadratic, it means this will solve any and all. Where graphing only worked well, especially if we had integer solutions and it crossed the x-axis. Factoring only works well as long as it factors. If its solutions are irrational or imaginary, factoring is not going to work. Completing the square works well, especially if it's just x squared or a single set of parentheses squared. If it's not, we have to default to quadratic equation or completing the square to get there. But this here shows us why this works, or how we can actually get to the quadratic equation from our general form. Okay?